All right, welcome back, everybody. We are on for our last session of the day. This session is all about digital twins. I am going to pass it over to our moderator for the last session. We will see you guys back here at 4 p.m. All right, good luck, guys.
Well, thank you so much, Hannah. And over the next hour, we're going to be discussing digital twin opportunities across the power industry. And joining me is Wesley Bausch from Southern Company and also Josh Berry from TVA. We're going to spend about 15 to 17 minutes each discussing our topics. And if you'll make sure to post questions in the chat. And at the end of our session, with any remaining time, we'll make sure to pose those questions to each speaker. And actually, I am up first with my pitch here. And so to give you some background on myself, my name's Bobby Noble. I am the program manager of both Program 216, which is the gas turbine lifecycle management program here at EPRI, and then also Program 217, which is the gas turbine advanced components and technologies. And so my background, I have a bachelor's degree in mechanical engineering from Clemson and a master's in aerospace from Georgia Tech. I've been with EPRI roughly 5 years. And before that, I was the director of the combustion lab at Georgia Tech for almost 10 years. And so it's great to be with you today and to start out with looking at our digital twin opportunities here. And part of this is ongoing work and work to be started that we're looking at here at EPRI. And so as we start out here, and I want to kind of bring us to a general understanding and baseline for what we're looking at with a gas turbine digital twin and how we're defining it within this work. And so ultimately, it's a analytical model that represents a physical system. So the gas turbine itself, we're trying to incorporate the physics there, but also letting the data itself lead us where we need to go and extract all the information that we can out of there. And so ultimately, the term digital twin definitely has a broad label for many types of analytical systems and other representations. And so as I click through here on a few of these sub-bullets here, the EPRI digital twin relies on integrated usage of both AI and machine learning. Ultimately here we're looking to encapsulate the physics-based model. So we're looking at high fidelity models. There's a great dependency there. We're looking to use AI as part of the training parameters within moving from unit to unit, even if it's the same frame type, or if you want to think about a car, if it's the same model, moving from one unit to the next, there's going to be some differences. And so using AI there to capture those and train, but then also looking to embed AI models into the overall monitoring and diagnostic system itself within the utilities here at EPRI that we work with. And so again, calibration of each of these unique models and looking to adapt to consistently, or constantly look at these varying systems. And so one thing to think about is really what we're looking at is a lot of time-dependent cases. And so, see if I can get my clicker, if I can go ahead and get advanced to the next slide. Oh, there we go. Well, so how can the digital twin help? So there's many cases here where we've already started to utilize digital twin, and I wanted to put this here to kind of get some ideas and understanding for what we're calling digital twin and how we're using it. And so ultimately trying to help determine the optimal operation under current conditions. So this is, kind of a real-time diagnostic tool. But then also our digital twin, we're looking at using to just leverage that existing data. What additional insights can we extract out of the data streams that are coming through? But then also how can we, as we have the next topic there, how can we provide greater insight into unit condition and operations? And so lastly, one of the greatest aspects of digital twin that we're exploring and specifically thinking AI and machine learning enhancements is around reliable forecasting. And so that's something of great interest for many aspects, from a maintenance standpoint, from an operations standpoint, and so forth. And so with this kind of brings me to the first challenge point that I want to address here. And so this is with gas turbine water wash optimization. And so as we look into this first challenge here, ultimately AI and machine learning tools have been used. Thinking about neural networks, Bayesian regression, and forecasting. One of the biggest challenges that we've had with this particular problem is just noisy data. And I'm sure everybody can empathize with that aspect is how can we get better insights out of such noisy data. And so the purpose here is just, in this particular case, is estimating the compressor section of the gas turbine, estimating that degradation. And so one of the key aspects, if you're not familiar with gas turbines, is that to get back or recover some of that degradation, you can do water washes. And so literally that is what it sounds like, using water to wash and rejuvenate that compressor. And so ultimately, when's the right time to do that? When's the best time to do it? There may be some best practices. There may be some, um, you know, calendar constraints of where things would, where you would like to have it happen. But ultimately, the way our estimator here works is by comparing kind of that frozen compressor health to one estimated through digital twin health parameters. And so ultimately, allowing here that the ideal model is compared to the current state of our gas turbine. And so the tool is currently actually being tested at one of our utility members for evaluation. And so from them, we're looking for feedback on usability, accuracy, and other possible improvements to incorporate in our next tool. And so ultimately, right now, as a test bed, this is being utilized through just a generic Excel spreadsheet. And so looking to further develop this and integrate it in real time in their system after we've kind of tried out the baseline aspects. And so just to kind of give you some insights into what we're doing, what you see here in the kind of on the right hand side of the screen is a plot of real data versus predicted data from the digital twin. So these dark blue points that you see are the actual data. And so your eye can catch that, yes, there's a downward trend. And as the slide has gotten bigger here for you to be able to see that a little better, you can pick out that downward trend. You can kind of average that with your eye. But one of the challenges is that why is that downward trend happening? Is that fully because of the compressor degradation? Is it because of maybe other aspects of the unit that is causing the data to look this way? And so ultimately, we're able to marry together the digital twin data and where it's forecasting with the next day, next week. And in fact, here you see days out. We're going several days out past, but ultimately looking to predict how low are we going to drop over the next several days. And so aspects here is that if you find an optimal time for you from an operation standpoint to do the water wash, then this kind of lets you know that where things are headed and how quickly. But then also maybe you're just looking for other parameters and wanting other insights to find the exact best time to get the most performance out of your unit. And so this is kind of what this tool is doing. And as we here we go, as we go to the next slide, looking at just, this is actually still real data, just drawn without the exact numbers on here, but looking at the trends of where your megawatt output is versus time. And one thing, again, to remember, many of these aspects that we're looking at are time dependent. And so with that, there's many things that join into those time dependent parameters as far as different operating conditions, again, the performance, the conditions of the unit itself. And so how does this all play together? And so the digital twin kind of is a layer and a next understanding for how your unit is progressing and where the optimal points to do that water wash and to not only recover those lost megawatts generation, but ultimately to do it at the most optimal time. But then the other challenge I want to point out is looking at just gas turbine monitoring and diagnostics in general. And so one of the big challenges is, I'm sure this is very similar no matter which part of, if you're in nuclear, if you're in fossil generation, advanced pattern recognition or APR software is a big monitoring and diagnostic tool. But there's some challenges to it. It's a great tool that makes it very streamlined to start looking at trends and other statistical aspects. But one of the biggest challenges is training data. And especially as units are becoming more and more dependent upon following renewables, and we're not a nice base load trend for gas turbines particularly, retraining these APR models is a huge amount of time that is spent from a monitoring standpoint. In fact, most M&D centers that we speak to offer up that they typically spend 80% of their time trying to really determine, is an alarm real or accurate? And if not, trying to retrain the model so that the alarm is taken care of and you can continue monitoring in a proper way. So ultimately with this, what we'd like to propose here and look at is using digital twin, AI, and machine learning as a combination here to help really in an automated way give proper training data sets for these units. And so essentially this is kind of a feedback to the APR software. And what we found actually in a lot of the work we've been doing with digital twin and other algorithm-based enhancements for monitoring is that adding another software typically is not what monitoring centers want. They want things that are integrated together and work well together. And so that's one of the things that we want to capture and start looking at is how can we feed back into the typical APR software packages. And so ultimately, we'd like to, in this case, for the opportunity, pair with some M&D centers to develop gas turbine digital twin automated reference data generation. And so essentially here using current operation pairing with historic data. And we can look at this both in an idealistic digital twin, calculated data plus the realistic data, and start to look at the proper referencing points. And so ultimately here there would be work to develop this interface, of course, between the digital twin and the APR software. Ultimately, we would like to be able to demonstrate this for at least 6 months. And the reason why is to pick up seasonal variability. That's usually where we start to see a lot of the issues is transitioning from one season to the next as the gas turbines are retuned. And even if you have auto tuning on your gas turbine, there's still many challenges that can be looked at in a 6-month period where APR retraining is problematic. And so ultimately we see this as a pathway for full implementation within an entire fleet. So we want to see this as a fleet usage capability. And so with this, I kind of want to just end with this summary slide. Just ultimately, where we've come with digital twin is trying to look at exact issues within each unit. There's going to be performance issues. There's going to be hardware issues, and how can we best understand these to get us to a point where we're not only improving diagnostics, but we're getting to be more prognostic and looking more into the future of our operation. And so really we're looking at this, and we've utilized artificial intelligence and machine learning to kind of marry the data, knowledge, analytics, physics-based models all together, and so capturing these all aspects. And so this is the end of my slide deck here, and I do want to remind you to make sure to put any questions you may have into the chat, and we will be glad to try to answer those either throughout, maybe through the chat itself, but then also try to address some of those live towards the end. And so as I transition here from my presentation, I want to welcome Wesley Bausch from Southern Company. And so he is in the Innovation and Technology Project Manager. And so they're at Southern Nuclear. And so Wesley's goal is to respond to requests from the functional areas of the organization to address technology needs and recommend solutions, and in turn supporting the implementation of these chosen initiatives. Wesley manages human and technical aspects of project implementation, focusing on continuous company success. His background is in he's focused on solutions around digital worker, spent fuel, pool filtration, radiation protection, advanced monitoring, and chemistry risk-informed sampling. And so previously he worked at corporate chemistry in the corporate chemistry department, and he's got a bachelor's degree in natural sciences from the University of Wisconsin. And so with that, Wesley, I want to welcome you and turn things over.
Hi, Bobby. Can you hear me okay?
Yes, sir.
Great. Well, thanks everyone for joining us here this afternoon. My slides should be popping up here soon and transitioning into my discussion. See if we can get at least the kickoff slide here going. Again, as he mentioned, my name is Wesley Bausch. I'm in the Innovation Technology Group for Southern Nuclear, one of the subsidiaries of Southern Company. I'm located in Birmingham, Alabama. Most of what I wanted to start kind of by hitting on was what our group is really all about, why we exist, why our chief nuclear officer finds value in having an innovation group, and what that comes down to is that Southern Nuclear is committed to improving the safety, operation, and just all around maintenance, how we operate our nuclear fleet. And right now we have 6 units, soon to be 8, very soon to be 8. With 2 new units at Vogtle 3 and 4 in Augusta, Georgia. And again, what we're trying to do as a group is, from a broad perspective, look for solutions that we can bring in-house that will positively impact how we operate and run our plants. Some of my effort does come in from internal also, that we have work groups, functional areas, whether it's chemistry, operations, radiation protection, that will come to us asking for very specific solutions. In the case of digital twins, it's kind of twofold. I've kept my ear to the ground as part of my job to look for opportunities to bring into Southern Nuclear. And I've also been receptive to groups such as training that have been looking for very specific types of digital twin technology that could improve their how they operate. So as far as areas of opportunity that we see for digital twins, it's pretty wide reaching, which is really what our group is kind of all about. Whether we don't have a very narrow focused thing to say, hey, this is what we're going to look for in innovation solutions. It's really a wide array. And as Bobby pointed out with a lot of things, he mentioned in reviewing my bio, I mean, we're covering XR, VR, we're looking at digital twins, we're looking at a lot of different technologies that could make life better for Southern Nuclear. But specifically, some of the things that I wanted to talk about were monitoring, assessing of plant systems. Bobby kind of hit on that a little bit with some operational data. I'm going to review a chemistry specific example, but really in the end, that extends out to operational data, maintenance data, radiation protection data. We have a wide plethora of data that in the nuclear industry. It's just finding something to do with finding something useful to put it into and get a return on. So the positives for SNC is just our mindset. As I said, that we've called it many different things in the nuclear industry, whether it's delivering the nuclear promise, business modernization, but we're always looking for ways to improve how we operate and really in doing so reduce cost of operating our nuclear facilities. So the biggest thing though is Delta is being able to make changes, being able to implement new things that won't negatively impact the operating side of things. And I think that's where digital twins stand out to me, is, as Bobby pointed out, it's being able to take that computer program and model a physical object without necessarily impacting that physical object while you're doing it. A bad word in the nuclear industry is experimenting. Well, we kind of want to experiment without experimenting on the live asset. Let's see if I can get my clicker going here. Oh, sorry, I went one too far. See if I can go just one slide. There we go. So the first example with digital twins, I think Bobby did a great job of explaining what a digital twin is, the basics of it. How I've always been taught, and the research I've been able to do in the 14, 15 months I've been in innovation and had a focus on digital twins, you can really break it down into a bunch of different categories, whether it's a component twin, something like a rotor, system or a unit twin. This would be like an aircraft or a combined cycle plant, an entire plant. An asset twin, such as a turbine or a steam generator, and then a process twin, whether that's in the case I'll go through a training process, but that could be a manufacturing process or anything similar to that. So the example I wanted to use here from my old life is chemistry data. So as I mentioned before, we have tons of data. It's being able to take that, put it into something where we can get something reliable to help us monitor, assess, and really, most importantly, predict any changes that either are occurring to our plant at the time, or as we're looking at the data, or help us predict, if we were to implement a certain change, what it might do to our plant. So that's the example that I have here. So a digital twin to enhance assessment of adverse trends. So if we were to have an off normal condition in the plant, could we look at a digital twin, use that predictive capability to tell us kind of where that would be headed, and if we made change X, Y, or Z, how fast we could recover from that abnormal condition. And same thing goes for changes with a chemical. So if we wanted to implement a new secondary chemical, is there a way for us to see, if we implement it at this stage in the secondary system, what kind of effects it would have on the chemistry in other parts of the system down the line? And then last but not least, one that I have listed here is sample and frequency. Is there a way that we could utilize a digital twin to justify changing our regime for sampling? We have pretty prescribed methods that we've used for a long time, whether it's diagnostic control parameters, EPRI requirements, regulatory requirements. They're out there, but is there a way we could shape how we implement them within Southern Nuclear based on the output of a digital twin telling us this is where we could go with it? So a couple future projects that we have. One tied into EPRI is they have their plant chemistry simulator that we've utilized within Southern Nuclear, and I know a lot of other plants have for doing just that. But right now, what they're looking to is to bring that more into a real-time setup, something that will allow us to utilize real-time data versus just the historical data, and model that continuous loop. So rather than just using that historic data and getting a feel for it, is to put it into some type of digital twin real-time monitor to allow us to assess it right there and continue to do that. Something we could probably easily tie into our M&D center, our measuring and diagnostics center. And then another item, as I mentioned above, that we're also looking at with a potential vendor is sampling reduction. Is there a way to utilize digital twin AI technology that's already out there and use it as justification for modifying how we the frequencies and frequencies that we collect samples on the site? And again, all in an effort to kind of work around reduction in staffing and reduction in really just resources in general. And we'll go to the next slide here. So that was a system unit twin example. Here's an example that's near and dear to my heart, being the co-chair of the EPRI Steam Generator Management Program team. in my previous role was the steam generator itself. And what I view this as an asset twin, as I mentioned in my opening. So here it'd be the ability to perform operational assessments of those steam generators, have some digital twin version of it so that we can model things before we would make changes, or to help better predict life of certain components of it. So steam generator is a very complex, it's not a simple heat exchanger. There's a lot of complexities to it. But the goal with our work with EPRI is to hopefully focus on one particular thing where we can really hone in, build a digital twin, and figure out how that model can help us improve or at least predict the life of components of a very expensive asset for our plants. So the first one, perform operational assessment of the steam generator. As I mentioned, could we plug this into a digital twin and use all that historical data that we have in nuclear to better predict the life of components based on the feedback from a digital twin model? And one particular item we looked at was tube, basically life of tubes. So when we have stress corrosion cracking or other physical and chemical mechanisms that impact the life of components of a steam generator, can we use a digital twin model to help us predict how they may have an effect, not just 6 months down the line, but 10, 20 years down the line, in hopes of getting some of these components to last the life of the plant. The second thing I wanted to mention was steam performance. So could we simulate or model changes that impact that steam performance? That's something that crosses over between engineering and chemistry, the chemistry realms, but something that we're always looking to get a better feel for. Is there a better way to predict what changes when we implement new chemistry or new chemicals into the steam generator, the secondary side, or make big changes to components from an engineering perspective in the steam generator? How will they have an impact on that steam generator performance? That steam performance, what drives the secondary side? And then the last thing I wanted to mention with that is again, with the digital twin AI type of analysis, could we use that as a simulation for corrosion product transport or species hideout return? Those are two things that are pretty important in the chemistry world, as far as things that we need to monitor and keep an eye on cycle to cycle to, again, overall get a feel for the health of those steam generators. Could we put that data into a digital twin model and get a better idea of what things we could possibly do to improve corrosion product transport or reduce hideout of ionic species in the steam generators? So future projects right now, I know that, as I mentioned, EPRI, the steam generator management program team, is looking to create a digital twins in a specific area. So right now, again, the focus is on analysis and prediction of integrity of the steam generator, specifically the tube wear life, or wear life of tubes, I should say. But that's kind of a start. But like I said, there's a lot of things that we could model in just that one component, and other components or assets that are part of a nuclear fleet that we could get a lot of bang for our buck if we had a digital twin model to start working through changes before we were to implement them at the plant. And then the last one I wanted to discuss, if we can get it up here on the screen. Sorry for the slight delays with my mouse clicker here. Process twin. So this is one, as I described, that was a training came to me last summer and said, hey, we're looking for a solution. We want to see the different levels of solutions. So whether that's, just taking a camera in the plant, taking 3D photographs of equipment, or all the way up to this, creating a virtual reality training environment. We want to see what we could do with a digital twin, of creating a digital twin of scenarios, basically training scenarios that we would train on otherwise just using a PowerPoint, or have to do physically in the field at those locations where we could have not only safety concerns, but from a nuclear perspective, there's radiological concerns around a lot of the tasks that we need to train to do. So could we create something that immerses our trainees in an environment that basically sat as close as we can without physically being in that realm. So a digital twin here, as you can see, this is a great picture of a project that you see down there at the future projects that we're working on. Something I'm working on with the Southern Company Services folks is they're looking to model an offload of a chemical on one of our generation stations. This is something that we do at nuclear sites too, not only with chemicals but emergency diesel fuel oil. That it would be of massive benefit if we could run through something like this multiple times over and over again in a simulated digital twin training environment without necessarily having that worker in the field going through it. And the model that we're creating as kind of a pilot for to present to our executives it really covers everything that we need, right? We're just, where can we expand that past just this pilot that we're looking? Is there a platform that we could utilize within the nuclear industry, scale it to us, or maybe scale all to Southern Company as a whole, to kind of create these training modules and create these environments where they can take care or take use of virtual reality to train and get people familiar with the actual tasks, the steps of the task, the process of setting up for the task, and even the procedure itself, having that procedure in hand and going through the steps before they're out in the field, one, getting actually tested on their ability to perform the task, but then to keep, especially with infrequently performed tasks, ability to keep that skill level where it needs to be to perform it proficiently and safely. So again, future project right now is looking at potentially at least piloting some type of training environment, a digital twin model of a real life chemical offload process, and see if we can build a program around that. And then last slide here before I end out my talking points. So just in general, what I wanted to review is Southern Nuclear, as well as I'm sure most of the other operating fleets in the nuclear industry, we're looking for more options to simulate those plant conditions or plant changes without necessarily impacting the operating units. It's not something, they're not down very often. Hopefully we can make it 18, 24-month cycles without having to back down in power too much. So that limits our ability to really implement new things or work on things. But I really feel with a digital twin in a lot of different ways, we could create that environment where we can experiment, we can operate, we can test things out before we decide to bring it back to the real life world and implement it within our fleet. So what we're looking for is vendors that can support nuclear specific projects in the area of digital twins, but again, be able to understand that our technologies, we have to meet that commitment of improved safety, maintain the availability of those units, and reduce operation and maintenance of our nuclear plant, that we need someone that can work with us, a very small niche, and understanding that we're kind of a unique technology, and it kind of requires unique solutions to meet our needs. So just wanted to end by saying that we continue to look for ways to innovate and find improvements for the nuclear industry, and we're really looking forward to possible digital twin projects that we could bring in within Southern Nuclear and really lead the industry with taking advantage of this technology.
Excellent. Well, thank you, Wesley. And as Wesley finished up here, I want to remind everyone to make sure to utilize the Q&A on your screen there. You can also put ideas. Wesley has done a great job continuing our discussion around digital twins. And so what are some of those ideas, maybe some of those thoughts that you have about this would be a great digital twin application? Maybe this would be a great digital twin in general. Maybe there's just general questions that you have that how do we implement this? How do we make it work? Whatever those questions may be, go ahead and put those in the Q&A or put some ideas in the idea box. We'd love to be able to follow up with you on some of those as well. And then after our next speaker, we should have a little bit of time to start answering some questions. So make sure to put those in the chat box there, the Q&A or the ideas box. And so we're making sure to monitor both of those. So again, thank you, Wesley. Great job in bringing some perspective from what's going on at Southern Company and some ideas there that you're wanting to implement. And so next speaker is Josh Berry. In fact, if you were on one of the earlier sessions, one of the fireside chats, Josh is a pro at this now. And so Josh is Senior Manager of Data Foundations with the Tennessee Valley Authority. And so he's in the enterprise data IT professional with more than 15 years experience in major IT project implementations, system architectures, and infrastructure developments. He's also has extensive experience acting as a coach and leader with various aspects of data-driven endeavors and analytic use case initiatives. He's led warehousing teams and integration teams and started analytics and data science programs. And currently, he's leading the Enterprise Data Foundations team, data governance and enablement. And so, with that, I think Josh can probably give us a lot of ideas and encouragement as well from his background with how to implement digital twin and some aspects. So I'm definitely looking forward to his talk here as he wraps us up in our session. So, Josh, welcome, and the floor is yours.
Thank you so much, Bobby. That was a heck of a lead-in. I couldn't have teed myself up any better, so thank you for that. And Wesley, great presentation. That was really fantastic. Again, just to say it out loud again, I guess, I'm Joshua Berry. I am the Senior Manager of Data Foundations for TVA in the Technology and Innovation Department. Primary focuses are more related around data enablement, metadata management, master data management, anything of that nature as far as putting the scaffolding around to really extract the most amount of value we can from our analytics. With that said, this reverse pitch is going to be a little different just by the very nature of what I've been tasked with at TVA, but I still think it's going to be really neat to see how the conversation kind of intersects. So with that, the plan is to give you a challenge, what we're in the middle of day in, day out right now, what we're really trying to tackle and get ahead of. A little brief background, not long, I won't bore you, but what got us here? What's kind of our past 2-3 years, and what did that look like that ended up putting us where we're at right now? Kind of what we're in the middle of right now, from a standpoint, what are we in the middle of to find at the moment? Where do we want to be? And then what's our ideal state? How do we get there? And with that, I forgot I'm in charge of this now. Uh-oh. Did it work? All right. So our challenge in a nutshell, I think based on the previous slide, you kind of gathered that I'm more foundational, enabling aspect of digital twins, AI, machine learning. So what we're setting out to do right now in this challenge is really to define what does our data fabric need to look like. That's what's been identified that we really want to establish from an enterprise perspective of how best to take advantage of these fundamental elements as digital twins get stood up. Where are the overlaps? Where are the reconciliations that might need to occur? And we felt that like the best way to achieve that was by producing a data fabric. So what's our data fabric, right? Well, first of all, the pipelines that hydrate the data fabric. We want to use augmented intelligence, artificial intelligence, those things, but we want to be responsible in doing that. So there's a data governance framework element to that we're trying to achieve currently. The data fabric elements, as we start applying AI to our models, different versioning, tweaking those models, and digital twins, how does that fit in that? That we're really creating this bedrock that all of these advanced analytics technologies can really tap into. So that's our challenge today. And we're going to cover a little bit more in this presentation of hitting on specifically different elements of those and what we're trying to achieve. Kind of what that carrot is on the end of the stick that's driving a lot of the decisions we're making for this. So brief history on what got us here. So 3 years ago, our leadership I think he just our CIO came to the conclusion that our data siloed everywhere. We've got quality issues that are rampant. There's interaction opportunities we're not taking advantage of. Let's try to get this from an enterprise state of mind. Let's try to fine tune this and shape it up to what it needs to be for the future. And that kind of led us on a 3-year path these past 3 years to really define a data governance framework. And we just now started bridging the journey of the sister team of data enablement adhering to all the guidelines and scaffolding of data governance. What does that need to look like? And as you can see, that is data virtualization, data twins, augmented artificial intelligence. How do we enable all of those things with wearing the data governance hat, making sure we're doing our due diligence with all of those things, with data access, data proliferation, data classification, downstream implications of when one element of that data is affected, what are all the implications it might have across our enterprise? Well, that really is spearheading the conversation of, hey, there's a lot of capabilities we could take advantage of now, but we've got to start building something that makes this repeatable, reusable, sustainable. And that really is what we're doing. That brings us to our challenge that I mentioned before. So where do we want to go? What do we really want that data fabric to be so our digital twins can stand on it? So different advanced analytics can stand on that fabric. I mentioned this at the top of the slide, but we want dynamic model usage. We want those things to pivot, learn, grow dynamically, super flexible. Dynamic data pipelines, right? That almost seems like, well, how can you have the other if you don't have that one? You're exactly right. You can't. We have to make sure we have dynamic data pipelines. That's kind of that's the cornerstone of it. But at that same time, what my concern is how do you do that in a very responsible way? I'm not sure if you heard me in my fire chat, but I'm a big proponent behind don't let specific use cases and the value attached to those blind you to thinking long term about what's sustainable and what are maybe some decisions that we should back up 5 steps and really think about how are we setting precedents with this, or is this going to paint us in a corner that it's going to be hard to back ourselves out of. Ethical considerations, those are huge. One, let's say data isn't exactly classified correctly. What if it's sentiment analysis? What if we're doing deep dive analysis on that? And just because we can do certain things, does that mean we should? So that's nested into a little bit of our outcomes that we're running into. impact, machine learning, digital twin. What is the impact of those things on our data governance framework? And how do we need to adapt it or evolve it into what it needs to be for this next data insight capability? And then we feel like if we hammer out those 4 other elements, we're going to unleash the power of digital twins across the board for enterprise use. There's going to be foundational elements in each one. They're going to be reusable, and that's where we want to go. You wouldn't think this would be so hard. Sorry, guys. Okay, let me back up. All right, digital twin strategy. These are all of the possible use cases we've heard through our business partners of things they're excited about. What are some scenarios that we feel like when we get to that point, we're going to be able to embark on a digital twin strategy to take advantage of some of these things. Vegetation management, asset deterioration, disaster forecasting, planning. I think you heard in the fireside chat as well, I was talking about outage optimization. How does one transmission line going down, what are the ripple effects across our footprint, our grid? These are really what is driving our initiative and our work every day of us trying to define this fabric and access layer. Our future, complete data democratization. That's where we want to go, right? It doesn't have anything to do with digital twins, you could say, But if you think about it in a different way, it absolutely does. AI, digital center of excellence. That's something we hope to achieve. This is a big one near and dear to my heart. The top one in the middle, trusted. If we're defining that base layer of that fabric, there shouldn't be any question when you go and you stand up a sandbox environment and you're wanting to explore possibilities. You shouldn't ever be in doubt that the data you grabbed was the right data to grab, and you can absolutely trust it. And you know who the owners of it is. So that's pretty powerful. And I think some of these are just supplemental. You can see just by the very nature of me naming those, analytics as a service. That comes to be in a much more powerful way than it ever has before. Real-time dynamic enterprise dashboards. Those are kind of elementary to digital twins, but it's a fundamental element. And then just simplified data layering across the board to talk about those interchangeable parts and building that master puzzle that you want your digital twin to be. And with that, that's it. I was down a little quick. But thank you so much. Please ask any questions away about the foundational elements.
Well, thank you. And I know that we do have a question in the chat, and I think this really is a question that we can all kind of take a different approach potentially at answering, and maybe Josh, since you're up, we'll start with you and some of your thoughts around this. But essentially, the question is involving verification and validation of digital twins, and basically that's seeming to be a challenge, and I definitely agree with that statement. So any thoughts on how to rigorously do the verification and validation, particularly when using kind of these machine learning and AI black box methods? So I don't know, Josh or Wesley's on the screen as well, if either one of you guys want to jump in and give your thoughts.
Bobby, could you say the question one more time? I'm sorry, you were choppy. I only caught like every fourth or fifth word.
Sure thing. I apologize for that. So with thinking about verification and validation of digital twins being a challenge, what are thoughts on how to rigorously do this, particularly when thinking about that most AI machine learning methods are kind of black boxes?
Wesley, you want to take that?
Yeah, I think just from my perspective, and I think how we have to approach it, at least for Southern Nuclear and probably most of the industry, is to utilize kind of that innovation team. I mean, there are a lot of things that you have to go over and verify if we're really going to use this technology to move our company forward. And I think it's utilizing groups like that, people that can dedicate the resources to running projects and being able to get the people together that we need to really vet something. But I think starting with what I pointed out in my presentation is just having a group that's willing to do that has the energy and desire to kind of bring these new technologies to the forefront in your industry.
Excellent, Wesley. And to be honest, that's one of the big challenges, and why I know in the gas turbine programs at EPRI, why we started developing our own digital twins, was simply because most of these applications are full black boxes. If you get something from the OEM or even a third party, the information is in the secret sauce that's in that black box. And so if it's all made public to you, then where's their IP? And so there's definitely some major challenges. There's challenges in understanding what the digital twin's doing, so thinking about the verification and validation, but then also how can you trust that digital twin information just in general? Do you know that it's doing what you think it's doing? And to a large extent, I can equate that to APR software, at least from my experience. Is that really doing what you think it's doing? Is your model doing what you think it's doing? And so I know that that's a big challenge, I think, for everyone in the industry is trying to figure out how to do that. And I think ultimately putting the right team together, not trusting, in really a lot of what we say in the gas turbine industry is trust but verify. We can't just blindly trust, and so I think as we look to integrate and try to use data and information, especially as Josh was pointing out with trying to make sure you know where your data is going. Maybe Josh, you can speak on some concerns maybe from that standpoint of where your data is traveling and trying to protect your information. Maybe you can make some comments on how you guys are trying to ensure that, even though these may look like black boxes.
Yeah, so I can't speak to the black boxes because we are right now at the point in our data strategy, we are doing it internal. I can tell you how we're being responsible with our data, and that really is to set a framework of data stewardship, data ownership, who's ultimately responsible for that data, classifying it, and what's the appropriate use for that data. Downstream implications of that data, what's acceptable for how that data is moved and kind of propagated throughout the enterprise. We have set up a framework that establishes those type of things, which is so important to get ahead of that and do that at the beginning of any kind of digital twin stand up. I think that framework will save you a lot of pain and misunderstanding in the long term. But going back to what you said about the black box aspect, I couldn't agree more. I think and it's the old adage of just being in technology for as long as you have, right? Bake in too much technology into something that handcuffs you to a specific solution. You're no longer tool agnostic. So you might not be doing what's best for the data. You're doing what's best for your vendor or who you're dealing with. So I couldn't agree more with that.
So actually, there's a new question that looks like it came into the Q&A. Does your data fabric make use of cloud resources? And I apologize for the abbreviation here that I'm not familiar with, or is it based on premise only? I think is what they're asking.
Yes, I think what they're saying is your fabric just on-prem? So does it only tap into source systems like old legacy system, or it doesn't have to be old, forgive me, but on-prem physical server warehouses, or do you create the fabric based on cloud components? And the vision right now, and we're already doing this a little bit, it's majority on-prem, but we do tap into cloud elements to establish that as well. Great question.
Excellent. And it looks like we do have a new idea, or at least a comment here that popped up. And so you shared a very comprehensive view of TVA's strategy. You specifically pointed to data governance. Any thoughts on a CDO or similar role?
Yes, we had one briefly. They have since went on to grow in a different area, which is completely fine. But we are in the spirit working with my leadership of trying to identify another one. I can't give timelines or anything like that, but it is important to the enterprise.
Excellent. So I do have one question that I want to maybe jump back over to Wesley and just, one of the things, Wesley, that you had, you gave us two different twin ideas or projects, one looking at process and one looking more at the asset itself. And so I guess as you guys move forward, now I know building digital twins is a step-by-step building block, system to some extent, at least as we're starting out here now. But do you see these being integrated together where the process twin talks to the asset twin and they start learning from each other and giving you an overall insight, which might actually bring into Josh, how is that going to drive the data governance crazy?
I could definitely, just in general, I could definitely see that being the desire of where we want to go with it. We don't necessarily want to take that middleman out altogether, but we want to be able for that seamless, like you mentioned, back and forth to happen without us having to actually go do anything. This year was a big, the last year and a half, I should say, was a big step for us to get a fleet-wide data historian project implemented. So we each site, whether it was our plant Hatch and down in Vidalia, Georgia, or our plant Farley down in Dothan, Alabama, we were running off different plant historians. So our first step was to get that all on the same basis, especially as we bring these 2 new nuclear units online in Georgia. The next step was to have all that data funneled into the same place, so that, as you said, that we have that kind of one-stop shop for where we can tie in these different projects, for lack of a better term, whether it's a digital twin project or some other type of AI data analytics project. So yes, I would say it's very important for us to get to that point. But being as it's nuclear, that as I kind of hit it at both the start and end of my presentation is a huge challenge of it. It's kind of what you were just asking about, cloud versus on-premise. I mean, that's just a very touchy issue when it comes to especially safeguards related data at nuclear power plants. So that is going to be the biggest challenge, is kind of getting past that last hurdle where we feel 100% comfortable with that interaction going back and forth without necessarily having that middleman making the tie all the time.
Excellent. So Josh, do you want to add anything there? Where is that last hurdle? Are we even close?
I think, yeah, you put that on me, right? No, I think it's a great question. I think kind of half the battle is just knowing that's what you got to be thinking about. I really do think that. I think as long as your head's there and knowing that eventually that's where the conversation's going. And I think the sooner you're prepared for that, the better we're all going to be. Right? That's about as short as I can say, because it's coming.
Yep. No, that's excellent. And we do have, I see one new question that came in that kind of still fits in this same thread, but how can we standardize an industry-wide framework for data collection and storage? I know that EPRI, I can speak for EPRI, and in a lot of our data work that we've been doing, even within our AI initiative, is looking to capture these data sets. And I know Jeremy Renshaw mentioned that at the beginning with kind of our Big 10 and starting to do this. But, part of this brings in, and I'll even add to it as far as, the challenge of data ownership and how valuable is your data. So I don't know if either one of you guys want to jump in and kind of make some comments around this framework for data collection and storage.
Well, just a general comment on that. I think it's utilizing the resources that we always do anyway. I don't think nuclear industry is unique in this, compared to other power or energy groups, but unique compared to other technologies in that we utilize counterparts, peers a lot, whether it's at a corporate functional area manager level, where all the functional area managers for a particular group get together and talk monthly about things and try to collaborate on these things. Whether it's through IMPO, we use IMPO a lot to guide common practices and common, as you stated, governance for doing things like this. And same thing with EPRI. EPRI, of course, extends past the nuclear industry, is that we have all these peer people that we can utilize to kind of create that standard way of approaching this that still fits into regulations and requirements from each industry, but gives us, like you said, that framework for how the best way to proceed.
Excellent, Josh. Do you have anything else you wanted to add there? Or?
Yeah, sure. So I really do think one of the most important things you could do when you're really advancing on your analytics initiatives, or really want to tap into the capabilities that you're wanting to drive at is to establish data community stewardship, information stewardship. So that covers both ownership, responsibility, and it also covers making sure somebody over a particular data space is driving to the most value that data space needs to be addressing. Like prioritize, always have 3 top analytics initiatives that we need to drive for that area. I just can't say that anymore. Whether you're ready for digital twins or whether you're ready to embark on a real-time dashboard, those roles are so instrumental in really making a data community what it needs to be.
No, that's great, and I think I don't see any other questions right now in the Q&A. But even if we end right there on just thinking about that, that's one of the biggest challenges I know that we have is that accessing data doesn't look the same for everyone. The challenges in nuclear are different than the challenge over on the fossil side. There's different data streams. There's different amounts of sensors being utilized. And so I know that as we look to continue to push digital twins further, uh, we can always use more data. We can always use more points and more understanding. But the challenge is we all have those hard to measure, hard to determine, really, you want to say impossible in certain cases, information that we just won't have. And so I think as we continue to have these conversations, put these data sets together, we've got a great opportunity for collaboration and trying to push the industry forward. So, guys, I really appreciate you joining me today on this session, and I think we've had a great conversation. And I appreciate all the audience giving questions and ideas as well. So, thank you guys so much.
And thank you again to all of our other speakers as well. We've had a great day today. We will be back tomorrow at 9 a.m. Eastern Time. You will get a reminder email in your inbox at 8 a.m. with, again, the link to join. It will be the same as today's link, but we'll send that over at 8 a.m. for you tomorrow. Thank you guys so much. Y'all have a great evening.